Hey guys, this video will show you a simple method for melee attack detection, most commonly used for fighting games. However, this theory section will evoke a shooter game, as I think they're pretty similar and it might help you understand better that way. First, let's talk about hit scan. In a shooter game, in order to know if you're shooting at something or someone, we use a technique called hit scanning. It is a calculation performed in the physics part of the game to determine whether a bullet has hit a target after being fired from a weapon. When I say physics part of the game, just imagine all the colliders you have in your scene. In its simplest form, it is done by casting a ray from point A to point B, looking at if there is any collider intersecting that ray. If there is, we take the time to check which one is it a wall, is it a player? If it is a player, then what body part did we hit? And using all that information that the hit scan has gathered, we can then create some visual, so we launch that bullet and then we calculate the damage caused, so maybe create a decal on the wall. So in today's episode, we're gonna do something pretty similar, but instead of using rays that we use from point A to point B, we'll create an invisible box on top of our player's attack animation. And we'll then check for every other collider inside of that box and then send them a message, pretty much just telling them that they've been hit. Alright, so here we are in the engine, and let me just show you what's going on right now. So I've basically got those two players. One is called player 1, the other one is called player 2, so nothing too complicated here. They're basically made of a character controller, so I can actually move them around, and this mesh renderer. Now this is only to give it some kind of, shape, and I can actually visualize it. But what's really going to happen in your game is the graphic mesh, the mesh that you actually use just to make animation and just everything looks really pretty. It's not really used in our context because we're on the physics. We're really focused on the physics, so all we really care about are the colliders. So you have a box collider for your head. You have some more rectangle shaped collider for the arms and the torso. So this is really what you want to focus on. So what I'll do in this episode, I'll actually toggle this mesh renderer off, because I don't really care about the visual side. We really care about getting that hit detection. So what I'll do here is, let's just assume that this is my character. It would be a little bit more defined, like shapes, an actual player or humanoid looking person. What I'll do is I will right click on my player and I will add a empty game object. This game object, I'll name it my colliders or something like that, just to make sure that this is part of my body basically. And inside of that I will create a new 3D object, cube, and I'll name this head. And now I will just take this object and scale it so it looks like an actual head collider. Now of course this would be easier to do if you had an actual mesh that would look like a humanoid, but in my case I don't. So I'll turn it off, and there we go. That would be the collider for my head. So during my hit detection, if something goes inside of this, then we're pretty much certain that it has hit the head. Let's keep going. We're going to do another one just for the sake of having multiple. This is going to be the torso, and the torso is basically just going to be a little bit longer, and it's going to be beneath the player. Maybe a little bit more thin, like that. And you just play around. Now, of course, like I said, like 3 times now, if you have an actual humanoid looking mesh, this is going to be way easier. But here it is. So my player actually looks like that in the visual mesh. And of course you could reduce the size of the head, maybe like that. And yeah, here it is. That's a visual mesh, and that's what we're not supposed to see. So in a real game context, this is turned off. The cube mesh over here are turned off, so you don't see those. And the actual visual mesh is on. So here it is. Now, what we're going to do is we're actually going to make another object inside of that player 1. So inside of that player 1, I will create another empty game object that I'll call something amongst the line of, this is going to be where my detection box are made. So say I'm about to slash my sword in front of my player, then I need to have an actual collider following that sword around. And that is going to be my attack colliders. Now obviously these needs to be animated if you have some kind of animation attached. Since we're not really into doing animation here, and we just want to get this melee hit scan thing going and working, then I'm just going to let you know that if you need to have some kind of animated collider, this is where you would do it in our context. So I will right click on that, create another cube, and this is going to be my sword hit or my sword attack collider. So let me just put that in front like this, and yeah, this is basically it. So if I swing my sword and something is inside of that box, this very box, that means I will hit that something. Let's also create another one. Well, first let's rename this for sword hit, and I'll just copy it, name this long kick, so you get another example of how this works. And then I can just take in my box down here and just extend this, and this would be a very an actual very long kick. And here it is. So these are the box are going to be testing the collisions. Now of course, like I said like 3 times, these are actually turned off in a real game, but since we actually want to see how this works, we're gonna leave them on. Alright, so here's our first player. Let's actually start coding a little bit. So we're gonna go under create fighter. I'll create a script called fighter. I don't want to get too fancy with it, but it's actually going to get a little bit fancy because I'm just going to implement some movement. So I'll quickly just add movement in here. Of course, you probably already have your movement function, but this is going to be super quick. So private character controller, that I'll just call it controller, private vector3 move vector, oops, and let's also add a jump in there. So private float vertical velocity, nice. In a private void start now, this is going to be controller is equal to get component. We're getting the character controller component, so character controller. And I'm going fairly quickly because, like I said, this is not part of the tutorial. It's just so I can have some movement going on. Now, in my private void update, what I'll do is I will be coding my movement basically, and we want to add a jump. So if controller is grounded, we'll use the one from Unity, of course. We've done a way better grounding function in the past, but since we want to get this done as fast as possible, I'll just use the one from Unity. If input.getKeyDown, if we hit keycode.space, that means we're jumping, and that also means that vertical velocity is going to be equal to jump force, which in this case I'll just put on 10. Now if I am not grounded, that means we need to apply the gravity. So vertical velocity is minus equal something like 14 times time dot delta time. Now move vector is equal to vector3.0, and I'm so used to doing this kind of stuff. That's why it's like, it seems super easy, but I just keep doing that like every day. So anyway, horizontal, and then times like 5 because that's my speed. And finally, move vector y is equal to vertical velocity, and then we apply the speed. So controller.move move vector times time dot delta time. Alright, so we've got our basic movement going. Let's just test it out. Let's make sure that everything works. So on top of my player 1, I will add my fighter script. And here we go. He's moving left and right, I'm pressing spacebar, and he jumps. So good times, everything seems to be working fine. Now what we're gonna do is we are going to add 2 things in my update. Those are going to be 2 different buttons, so say key code, whatever, 2 other keys, and one of them is going to be used for a sword slash, and the other one is going to be used for the long kick attack. Let's actually create a function before we do that. So the function is going to be called private void launch hits or launch attack. And what I'll actually send in parameter is I'll send it a collider. So collider call, which is basically one of these. So either the sword hit collider or the long kick collider, these things. And before we start implementing the launch attack, let's also make sure that we know which attack we're actually launching. So what I'll do is I'll declare a public collider array. So public collider array, this is going to be my attack hitboxes. Now, what I'm going to do is say we are in the void update. And if I hit the key, so input.get key down, if I hit the key G, then if I do hit that G key, we will do a launch attack using the collider at the index 0. So attack hitbox at the index 0, which in our case is whenever we do create that public collider array, we'll just put that J is going to mean, say, the // we're going to be putting the / hitbox at the index 0. Now let's take this again. Let's just drag and drop, not a drag and drop, but copy down here, and say we're actually hitting H. If we hit H, let's do the second attack. And now, we can actually go ahead and make our collider array. So, where is it? My player over here. Player number 1, we have 2 different attacks. Not 22, my bad. And the first one is going to be the sword hit, and the second one is going to be the long kick. And notice that's all I drag in here. I drag the box collider, and that's all it needs. Right. So everything is pretty much set up. Now if I press G or H, we're going to have the launch attack being called with a different collider. Now how exactly do we look for, well, other colliders inside of it? What we're going to be doing is something called overlap box, which is a function that is inside of the physics namespace, or physics class, my bad. So here's what I'm going to do. I'm going to do var calls is equal to physics dot overlap box. This is the overlap box. Now, in some games, and I'm just mentioning that on top of my head, in some games like Super Smash Bros. Melee, they're not using box, they're using sphere colliders, and there's multiple of them. You might want to use that. It's actually faster to use sphere, because collision detection for sphere is really cheap versus any other kind of, well, it's pretty much the cheapest. Now, it's a little bit hard to do, though, in our case, because, say, you're extending your arm or you're having a sword slash, you would either need, like, 4 different little sphere collider, and that would be a little bit messy. Or you could have a single box collider. So it's up to you to just decide which one fits your needs the best, but the function is basically the exact same thing. Instead of sending like your box collider in there, you actually just send a position in vector 3 and then a radius. But let's go back to our overlap box. What we're going to do is we're going to say physics overlap box, which returns you a collider array, by the way. So in case you don't like having this var thing here, you can just say collider array calls is equal to overlap box, and then what we're going to send in here is we're going to send everything that comes in parameter. So you see that collider over here? We're going to do call dot bounds dot center, and now the second one is the half extent. Half extent is pretty much just the size of your box. So just imagine yourself that you have a box that is 1 meter by 1 meter. That means the half extent would be 0.5 on one side of the center and then 0.5 on the other side of the center. So if you decide to put, say, 1, 1, 1 in here as a vector 3, you're actually going to get a box that is 2 by 2 by 2. But we don't really care about that because we're getting everything we need in our collider parameter. So we'll just use call.bounds.extent. But I'm just mentioning that so in case you don't want to send a collider, you can actually just create your box on the fly here. You don't actually need to have one passing parameter, but I think it's so much easier to just have one there. And then the next thing is you need an actual rotation on that, so we'll say call.transform.rotation in case our box is a little bit rotated. And then finally, it takes in a layer mask, which we haven't done, but we're about to create that. So let's do layer mask dot get mask, and let's actually create a layer for our hitboxes. So I'll just call that hitboxes. or hitbox singular. Alright, and now when we actually play this, let me just do a debug.log in there. So debug.log, or you know what, even better than that, we'll do it for each. So for each collider C in calls, debug.log, and we're gonna say c.name, so we get the name of what we're actually hitting. Alright, now let's just assume we press play on this. It is not going to work. Just say that we hit J or G or H, nothing really happens, but technically it should, because this box actually intersects with the torso at the same time. Now I know he's pretty much just hitting himself, but we haven't done that check yet, so we should at least get the debug.log. And that's not the case because the layer is not right. So our overlap sphere only tests against the layer that we've put in the overlap box. Did I say overlap sphere? The overlap box only tests against this very layer. So everything that can get hit should actually have this hitbox mask. Now, this long kick and the sword hit are not things that can get hit. They're not part of the body. They are part of the attack. Now, of course, you could animate your body to just be a little bit more forward while you do the attack, but in the end, this is not part of the things that should get hit. So under my colliders up here, we're going to go under layers, add a layer. Now, this one doesn't exist. Let's just call this one hitbox. Well, actually, let's just call it the same exact thing that we've called our get mask parameter here. Now let's just make sure that it's set. As you can tell, it's not set, so we're gonna go back on my colliders, set hitbox, and yes, you gotta be applying this to every single children. So now the head and the torso are part of the hitbox layer. And if we go back in the game, press H, as you can tell, when I'm pressing G, I'm getting this torso because my sword hit, this thing, is actually colliding with my torso. Now if I press H though, I don't get anything, and that's because it's a little bit off, basically, as you can tell. If I just drag it in here and now I press H, I hit my torso as well. And what if I actually move this here and I press H? I don't get anything, and the reason is quite simple, is because these two attacks are not part of the body. But now if I put my long kick in my face and I press H, as you can tell, I'm colliding with the head. This is going to be fairly useful a little bit later on when we want to check which part of the body we've hit. So let's quickly go back in here and start fixing a few things. So in our for each array, we're going to keep the for each because I think that's quite useful and it's actually required here. So in our for each array, what we'll do is we'll make sure that whatever we're hitting is not part of our own body. So let's do a quick check. If c.transform.parent, and is that going to work? So we're starting, say, from the head, dot transform, which is this thing here, dot parent. So we go on my collider, but that's not me. Okay, so we're gonna have to do dot parent again to reach the player. So if c.transform.parent is equal to transform, my own transform, then we're gonna say continue. We're not gonna break, we're gonna go ahead and check for the next one. So this is basically like a return statement, but only for this for each iteration. So if there's multiple colliders inside, then we're simply going to skip the one that are ours. And we're gonna go ahead and just keep checking until we find either nothing because we ran out of colliders, or we find something that is not part of our own body. And let's say that we do hit something. Let's do a debug.log, and we'll just say it here. So debug.log c.name. I will quickly do that, duplicate my player. I'll actually remove this one and duplicate this guy. Move it about here. Let's rotate him and his colliders like so. 180, let's do that here. Press play. And I'm actually going to disable his fighter because I don't want him to be on the same inputs as me. So let's just assume I walk, I press on H, nothing happens. That's my long kick, by the way. I press on H, nothing happens, still doesn't happen. Now, as I get closer, as you can tell, oh, we have a bug here, by the way. We're gonna fix that in a moment. But as I get closer, and now I press H, I'm hitting someone's torso, which in this case is the player 2 torso. And if I just jump and I try to actually click here, as you can tell in my debug.log, I have actually hit him in the head using my long kick attack. So we know that we actually hit somebody else now. That's a good thing. Let's quickly fix the issue that we just saw like a moment earlier. In the attack collider, both box collider, we want them to be on trigger, and actually, you know what? Even our own collider, we want them to be on trigger. What this is going to do is basically they're not going to be acting, they're not going to be blocking anything, so they're not going to be collision. They're going to be considered as trigger only. You know, trigger collider are pretty much the things you see, say, in racing games. When you're about to reach the end, the game needs to find a way to actually know that you've entered a certain zone, but if they put a wall in front of that zone, then you're just gonna end up like having a face collision with that wall. So if you don't want to have any collision on it, but you can still use it to detect stuff, you're gonna be making sure that your colliders are on trigger. Good times. Now it should be fixed. Again, let's quickly test that. And it is. And I managed to kick him in the head. Good times. Nice. Let's actually calculate the damage now a bit, because we're going to be modifying our damage if we hit him in the head, of course. So float damage is going to equal 0. Let's do a switch case. In case that c.name, we're going to use the name to actually check which part of the body we hit, but of course you could be using tags, you could be using any other kind of detection you want. So in case we're hitting the head, let's do damage is equal to 30, and then let's break. In case we're hitting the torso, then damage is going to be, damage is going to equal, say, 10, and then we break again. Let's do a default, just to make sure we don't end up with nothing. So default debug.log, and let's do unable to identify body part. Make sure the name matches the switch case. So this is basically for us when we make the game. We don't want to end up like facing some kind of bug that we don't understand. So if it hits something and it's not able to find which part of the body it is, so is it the head, is it the torso, that pretty much means that we've written this here not right. So we should be writing it this way, capital H-E-A-D. And what else do we need? I think that's pretty much it. Now that we've done that, we've calculated damage, we can send a message to this guy. And just tell him you've been hit. Now, of course, this is not something I can really tell you how to do, because everyone's going to have their own functions at some places. However, what I can do is implement it in something that we've done last week. If you guys remember, last week we've made a health bar, so I'm actually going to implement it here. Now, if you guys actually watched the video last week, you would realize that we have this function called take damage. And the whole script can be found in the previous episode of Game Mechanics, so if you're watching this on the playlist, you can just click on the one just on top of this video. And we pretty much have this function called take damage, and that's what I'll be calling from my fighter. So all I have to do is actually just say send message upwards, take damage, and the amount of damage I send is the one I've calculated up here. So this is what we're going to do really quickly. I'm going to implement the health bar in this. It should not take too long. So let's just say we hit the guy. Now take damage has no receiver because we don't have health bar. I will go ahead and go under my player 1 up here, and I will drag and drop my health bar script. Same thing goes for the player number 2. And these health bar, they take in parameter an image and a text that we'll quickly make. So under my UI, of course this has been covered in the last episode of Game Mechanics, so you can go check that out if you wish. So I will quickly do this, anchor this top right, maybe give it a small margin, who knows, 20, minus 20, the height is going to be about 50, width 300, maybe 375. and that's going to be the background. So the background is actually going to look like that. That's the background, and beneath it is going to be the current health point. So let me just quickly change the color of that to a bright green, put the anchor on the left side, and we're going to be playing with the size here like that. So current HP, and let's also create that ratio text. Beneath it, I'll do a text ratio, center it, make it on best fit, because why not? And here it is. That's our first health bar. Oh wait, is it? No, it doesn't seem to be working. Hold on. I'll just put it as a children. Is that going to work? Yep, that's going to work. Alright, best fit, and here we go. So that's my player 1 health bar. HP 1. I'll copy it. This is going to be HP 2, which is basically the exact same thing, but the anchor is going to be up here. And the current HP anchor point is going to be on this side. Let's quickly plug this in our script. So player 1, current health bar, this is going to be the current HP, and the ratio text is the text just beneath it. Now player 2, current HP, and then ratio text just beneath it. Press play, and we should actually have a result here. Now if you remember properly, we have this first attack, which is the sword hit. Now I'll just go ahead and spam this by hitting G on the keyboard. Right now I should not get anything. Now I reach the torso, I should hit him for 10 points. I think my health bar is actually on 150 HP, so 10 hit points actually is worth 7%. Now if I take my sword and I actually manage to hit him in the face, he should lose more, as you can tell. So those are critical hits. Now same thing applies for this long kick. And there you go. And that's pretty much it actually, guys. That's pretty much how we do the melee detection. Now of course all you need to do to actually turn this into a real fighter game is actually put some kind of cooldowns and block the user from being able to move while he's doing those animations, and of course animate your colliders. Other than that, I hope you guys enjoy, I hope you guys learned something. If you did, please leave me a like, really appreciate that as always. And if you have any comment or question, please leave them in the comment section below, and I'll try to answer them as soon as possible. Other than that, please subscribe for more, and I'll see you guys in the next one.